So by now we've looked at measures of central tendency. We've looked at mean, median, mode. We've also looked at the range of data as well. Remember, range is not a measure of central tendency, but it kind of goes along with mean, median, and mode. It's often kind of included in those kinds of questions. So I want to kind of show you, I want to talk you through the notes that you have in lesson 3 here, because it's a pretty big idea and it can be a little bit kind of weird to try to make sense of on your own. So we're just going to talk about what's going on in lesson 3, and I'll show you, I'll work through an example calculation and let you guys do the rest. And then in the next video, there'll be some answers that you can check to make sure that you did this work correctly. Okay, so we've got Team A and Team B here. So we've got 5 basketball players here, 5 basketball players here, and if we actually pulled out rulers, measured their heights, added up their heights, and divided by 5, we would see that they have the same mean height, meaning, right, that they have the same average height. So, well, but these teams are clearly different. The average height on the team is the same, but we have some pretty obvious differences here. And you can take a second and write down what those obvious differences are and think about which team you would rather have. Like which team would you rather coach if you wanted to win a basketball game? And there's pros and cons for both, and it doesn't matter, okay? But what I do want us to see is we want to think about a mathematical way to describe those differences that you can see. If the average height is the same, but clearly, I mean, Team A, everyone is about the same height. In Team B, we have some very short players and some quite tall players, right? Which is why the average works out to be the same. But how do we describe the differences? How do we describe the fact that these players are all about the same height and these players have a wide range of heights? Okay, what's the mathematical way to do that? Well, the way to do that is to talk about deviation. Okay, and we're going to use standard deviation. Standard deviation gets measured, or kind of gets the symbol sigma. Okay, and that's a Greek letter that you can see this little kind of note down here at the bottom of your page. It tells you about sigma. Okay, and we also talked about x bar before, being the mean. So what we want to look at is we want a mathematical way to describe the differences between each person on the team and the average. So if everyone here is the same height, then nobody really deviates from that average height, right? It would have a low deviation, a low standard deviation. On Team B, we've got people that are much shorter than the average and people that are much taller than the average. So we have more deviation away from that average. It deviates further away from that mathematical mean. Okay, and we can put a number on this because that's what we do. It's math class. So our standard deviation has some important points. It's a measure of dispersion or scatter of data values in relation to the mean. So how far away are each of the data values compared to the average? A low standard deviation means that most data points are close to the mean. A high standard deviation indicates that most data values are far away from it. We would say that Team A has a low standard deviation and Team B has a high standard deviation because most of the points are different than the mean. It's more complicated to calculate, but we use it a lot in statistics. It's a really important measurement in statistics. You know, if somebody says, well, my average mark is 80%, a very smart thing to do would be to ask them what their standard deviation is. If their standard deviation is very low, then they consistently get 80% in courses. But if their standard deviation is really high, that might mean they have some very low marks and some very high marks. Okay, so standard deviation tells a much better story of what's going on. Now, big idea here also is the unit that standard deviation is measured in is the same as the data. Okay, so if you're recording heights, of these guys, and we calculate the standard deviation. The standard deviation would be measured in centimeters or inches or whatever we use to measure the height of our players. Okay. In this course, we're only going to be calculating standard deviation for an entire population, not a sample. So that's going to create some kind of some discrepancies in how you use your technology. And if you Google things, you're going to see a lot of SX instead of sigma X. We want sigma X because we're just going to consider all of the data we have to be part of. So how do we calculate standard deviation? Well, it's a little bit complicated, and I promise you I will make it easier for you in a bit. I want you to work through these steps first. So first, we need to find the mean. So we represent mean as X bar, and then you get this really cool kind of symbol here. This big fancy E means you add up all the values. Because in math, we really like to keep things simple, and we like to write everything symbolically. So how do we say we want to add up all the values? We put this big fancy kind of E in front of it. Okay, it's epsilon, whatever. You're learning Greek here today. And then we want to divide by n, and n is our number of values. Well, you already know how to find the mean. This is just a fancy way of writing it. Okay, what do we do next? Well, standard deviation is this crazy thing here, which actually isn't terrible when we break it down. We take each data point and subtract the mean. Okay, so x minus x bar, so each data point minus the mean, we square it, we add all of that up, and then we divide by how many points we have, and then we square root it. Okay, this is not a measure of central tendency. Okay, just so we're clear, this is not a measure of central tendency. It's a measure of consistency. I should spell that right for you. Consistency. Okay, so it's how close each of the data points is to the mean. All right, let's take a look at what this means. All right, so the next page of your notes has these 6 steps. So it tells you, calculate the mean of the numbers. Determine the difference between each number and the mean. Okay, and you can get a negative difference. That's okay. If your number is smaller than the average, right? That short guy on the basketball team is shorter than the average height, you're going to get a negative number. That's okay, because the next step we do is square them. Remember, when you square a negative number, it becomes positive. We add up all those squares. That's what that big fancy E there stands for, right? Oh, it's a Greek letter, sigma. Sorry, I called it epsilon. Wrong one. Okay, Greek letter sigma. It's capital letter. And then we divide by how many data points we had, and then we square root it. Okay, which is really long. You do not need to memorize this. Okay, but we do need to work through it a couple of times. So in your notes, you have the standard deviation for Anna kind of already written out for you. What I want you to do is follow along and just kind of notice what I'm doing. I tried to highlight little notes for you, but in case it doesn't make sense, this is what I'm doing. Okay, step 1 is to find the mean. Well, here's all of Anna's data points. So how do we find the mean? We do 36 plus 41 plus 43 plus 39 plus 45 plus 27 plus 40 plus 37 plus 31 plus 28. Okay, and that equals 367. And we do 367 divided by 10 because we have 10 data points. So we get a mean of 36.7. Right? That's X bar. X bar equals 36.7. So you know how to find the mean, right? We're finding the average. So once we have that mean, now we take each data point and we look and see how it compares. So we take 36 and we subtract X bar, 36.7. Okay? And we get in this case, 0.7, because this value is lower than, or sorry, negative 0.7, because our x is lower than x bar here. Then what I want to do, actually I should do this in my calculator, I want to take that difference, and right away if I square it, I can just write that down on here. Okay, and I'm going to do the same thing. 41 minus 36.7 is 4.3. Square that, 18.49. 43 minus 36.7 equals 6.3 for this, and then square that, and I get 39.69. Okay, I'm going to pause the video and do the rest. Okay, so now what I have is I have step 1 done where I found my mean. I have step 2 done where I found my deviation, right? How far away is each point from that mean? And I kind of did step 2 and 3 together because I already had the number in my calculator. I just found it easier to square everything. So I squared each of those values independently, right? So that's step 3. Now all I want to do in step 4 is I want to add up this column, right? Add up my square of deviation column. So I need to add up these numbers, 0.49, 18.49, 39.69 plus 5.29 plus, whoops, 68.89 plus 94.09 plus all right. Hopefully I didn't make any mistakes there. I'm trying to rush so you don't watch me put numbers into a calculator all day. And when you add it up, you should get this number here. Okay, and that's good. I must have put it in right because I got that number in your notes. Square of my deviation, right? I've added up this part. Now what I need to do, excuse me, step 5 is take the sum of my deviation, square of deviations, and divide by how many values I have. Okay, so I'm going to divide that by 10, and I'll get 34.61. That's my answer. And now I need to square root, because I squared all those values up here. I need to square root. And when I square root, just divide that by 10, so it's in my calculator, square root my answer, I get 5.88. So this means that sigma equals 5.88. Whoops, I should let you see that, sorry. Okay, so we found the sum of our squares, we divided it by our data points, and we square rooted. Okay, and that gave us our sigma for Anna. So again, you do not need to memorize these steps. Study card just yet. I think it's really important that before I show you how to get these answers really quickly, that you really do the work to see where these numbers come from. So they're not just kind of magic numbers. You can see where they come from. So what I want you to do now is go through. Well, if we go back to this page, we can see Anna has a mean of 36.7 and she has a standard deviation of 5.88. So you have spaces to do your work for Patrice and Morgan and Paige and Star. Okay, so find their means and standard deviations using this process. It'll take a little bit of time, and you'll really get to know your calculator really well while you're doing it. And then in the next video, I'll give you the answers that I got, and we'll compare them, and then we'll see how we can use those to answer some questions. Like, what are we going to do with this number? What are we going to do with this sigma that we spent all this time calculating? Okay, good luck.